In today's question, we have to calculate the number of moles of KMnO4, that is potassium permanganate, required to oxidize each 1 mole of the ferrous sulfate, ferric sulfate, ferrous oxalate and ferric oxalate in acidic medium. So we will find the solution of this question. Now it is given that in acidic solution, the KMnO4 will oxidize the other 4 chemicals. Now if it have to oxidize other 4 chemicals, it have to reduce itself. So in acidic medium, the reduction reaction of KMnO4 will be like this. In acidic medium, it is in acidic medium, the reduction reaction of KMnO4 will be like this. KMnO4, no need to write K, just write the MnO4. Negative you can write. In acidic medium, this KMnO4 will be reduced as Mn2 positive. Okay. Here Mn oxidation state is +7 and here the oxidation state of Mn is +2. +7 and +2, that means the Mn here have received 5 electrons, +5 electrons. That's why its oxidation state has reduced to Mn2 positive from Mn7. Okay, this is clear. This is in acidic medium. This is reduction reaction of KMnO4. In this way, KMnO4 reduces itself in acidic reaction. That means where Mn +7 will take up 5 electrons and that will be converted into Mn2 positive. This is a reduction reaction of KMnO4 in acidic medium. Now we will take each one of this to calculate the amount of KNO4 required. Now first of all we will take FeC2O4, that is a ferrous oxalate. First we will take FeC2O4. This is a ferrous oxalate. Ferrous oxalate, why? Because oxidation state of Fe is 2 positive and this will be 2 negative. Now this ferrous oxalate will oxidize. Fe2 positive will convert into Fe3 positive. Okay. Now this will oxidize like this. Fe2 positive will oxidize to Fe3 positive. And here the C2, that is carbon, the oxidation state of carbon is, what is oxidation state of carbon here? We can easily calculate. C2O4 2 negative. This is the ion. So total oxidation state means, suppose we have to take his oxidation as X. So 2 into X minus, because oxygen will be -2. -2 into 4 -8 is equal to charge on the ion, that is -2. So this -8 will go this side, will become +8 and 2x will become +8 -2 6. So x will become 3. That means oxidation state of carbon is here +3. Okay. Because oxalate will convert into oxide, that is carbon dioxide. Here C is 2. Means we have to balance this reaction in terms of C only. No need to balance reaction in terms of each and everything. Only what is oxidized or what is reduced, in that term only we have to balance the reaction. So ferrous oxalate in Fe will be oxidized to Fe3 positive. Here Fe +2, here will be +3. Carbon is here +3 and here +4. Means both Fe is also oxidized and carbon is also oxidized. Now we have to calculate the number of electrons that is removed from this compound. In case of Fe, it was +2 and it's become +3. That means 1 electron is removed. For this, 1 electron is removed. And for this, here C was +3 and here C was +4. That means from here also 1 electron removed. but here are 2 carbon atoms. So for 1 carbon atom there is a removal of 1 electron. So for 2 carbon atom there will be removal of 2 electrons. So total electrons removed will be plus 3. That means when this compound is oxidized, that means there is the removal of 3 electrons. Clear? This is 3 electron is removed from here. Now this is a oxidation reaction. This is oxidation reaction, and it was a reduction reaction. For oxidation of this ferrous oxalate, 3 electrons are removed, and when there is a reduction of MnO4 negative, 5 electrons are accepted. I mean, this is a reduction reaction, this is a oxidation reaction. Now we have to balance this reaction in terms of electrons, because here are 5 electrons that is taken up by the permanganate ion, and here is 3 electrons removed from the ferrous oxalate. So we have to balance this reaction. So for that we have to multiply this reduction reaction. That is, reduction reaction is 5 here. That means 5 electrons are taken by. So we have to make it 15, because we have to multiply this equation by 3. So at least there will be the balance of electrons. Now when we multiply 3 to this reaction, it will become 3 MnO4 negative plus 15 electrons gives 3 Mn2 positive. This is a reduction reaction. And here we have to multiply this whole reaction by 5. So we will multiply here by 5. So 5 FeC2O4, that is 5 ferrous oxalate. We also multiply by it by 5 Fe3 positive, plus here we have to multiply by 5, so it will become 10 CO2, plus it will become 15 electrons. So now here also 15 electrons and here also 15 electrons. That means when we will add these two equations, electrons will be get cancelled and remaining will be balanced. Now this is a reduction reaction, this is oxidation reaction. Now you see 3 moles of MnO4 required to oxidize 5 moles FeC2O4. That means 3 moles MnO4 required to oxidize 5 moles of ferrous oxalate FeO4. Okay. Suppose now this is only 1 mole. Then if it is 1 mole, then how many moles of MnO4 required? So when it is only 1 mole of FeC2O4 is there, that time this 5 will go this side, so it will become 3 by 5 moles of MnO4. Okay. Now for ferrous oxalate, 1 mole of ferrous oxalate we required 3 by 5 mole of MnO4. So for ferrous oxalate, for this thing, for ferrous oxalate we required 3 by 5. For what? Ferrous oxalate FeC2O4. Now for take another compound, that is Fe2 C2O4 thrice. Name of this compound is ferric oxalate. Okay. Now you see here oxidation state of Fe3 positive, because this is ferric oxalate. So oxidation state will be higher. It is 3 positive. And carbon is only plus 3 as it was before in case of ferrous oxalate. Now because Fe it is higher oxidation state, so it will remain as it is. But here is carbon oxidation is plus 2 and oxalate will convert here into carbon dioxide. And here carbon oxidation state is plus 4. Okay. And here number of carbon moles will be 2 into 3, 6. So we have to balance that carbon elements. We don't have to balance each and every elements of the reaction, but what is oxidized or reduced, only we have to balance that thing. Now you see carbon is oxidized to C4 because it was plus 3 oxidation state. Now from plus 3 it has become plus 4. That means one electron is removed from the carbon atom. So how many atoms are there of carbon? There are 2 into 3, 6. So number of electrons removed are 6 electrons. Clear? That means to oxidize 1 mole of Fe2C2O4 thrice, we have to remove 6 electrons from this compound. Now you see here there are requirement of 5 electrons and here are requirement of 6 electrons. So this reaction is not balanced in terms of electrons. So we have to balance this reaction in terms of electrons. So we have to multiply this reaction by 6. So it will become 6 MnO4 negative plus 6 into 5 30 electrons. Here will be 6 Mn2 positive. This is first reduction reaction. This reaction we have to multiply by 5. So it will become 5 Fe2 C2O4, okay, thrice. It will become 5 Fe3 positive plus it will become 30 CO2 plus it will become 30 electrons. Okay. Now at least in terms of electron this reaction is balanced. Reaction, when we add these two reactions, there will be the no electrons will be removed because it will get cancelled. Now you see in these two reactions 6 moles of MnO4 are required to oxidize 5 moles of Fe2 C2O4 thrice. Okay. 6 moles are required to oxidize 5 moles of ferric oxalate. So for 1 mole of ferric oxalate, so 1 mole of ferric oxalate C2O4 thrice, we have to take this 5 to this side. So it will become 6 by 5 moles of MnO4 negative. Okay, clear? So for 1 mole of Fe2C2O4 required 6 by 5. For what? Fe2C2O4 thrice. We also calculate number of moles required of MnO4. The third compound is a ferrous sulfate. Now write here formula of ferrous sulfate, it is FeSO4. This is a ferrous sulfate. Now we have to write the oxidation reaction for the ferrous sulfate. Now you see ferrous sulfate here, oxidation state of Fe is plus 2. So it will oxidize to Fe3 positive. Okay, that means it will surely be oxidized. Here oxidation of S is plus 6. Okay. And in sulfur there is only 6 electrons. So we cannot oxidize S more than 6. Because we can only remove 6 electrons and not more than that. Because highest number of electrons in valence shell of sulfur is 6. So sulfur cannot be oxidized. So there is only oxidation of Fe2 positive to Fe3 positive. That means here is a plus 2, it is a plus 3. That means there is a removal of 1 electron. Clear? Now you see here are 5 electrons, here are only 1 electron. So we have to balance this reaction. 5, 5, it will become 5. That means we have to multiply this reaction by 5. We have to only balance the elements which are oxidized or reduced. Now you see 5 electrons both are same. It will get cancelled out. That means when 1 mole of MnO4 negative is required to oxidize 5 mole of ferrous sulfate. So if there is only 1 mole of ferrous sulfate, that means when there is only 1 mole of ferrous sulfate FeSO4, that time we have to take this 5 this side, it will become 1 by 5 moles of MnO4 negative. Okay. So for 1 mole of FeSO4 we required is 1 by 5 moles of MnO4. It is for FeSO4. That is a ferrous sulfate. Remember this thing. Now last compound that is remain is ferric sulfate, last compound. So you have to remember this ferric sulfate. If you write here ferric sulfate, FeSO4 thrice, here is 2. This is a ferric sulfate. That will be oxidation state of Fe is +3. So we cannot oxidize Fe beyond +3. So it will remain as it is, +3 only, it will remain as it is. And second, here sulfur oxidation state is +6. It will not go beyond that thing, beyond +6. So this compound overall cannot be oxidized by MnO4 negative. So there will be no reaction. No reaction. Because there is no oxidation reaction of MnO4 negative with the Fe2SO4 thrice. So we don't require any moles of MnO4. Now whatever moles of MnO4 required to oxidize 1 mole of each we have calculated here. Now we just want total mole of this thing, MnO4. So total moles, that is total moles of MnO4 negative will be 3/5 in case of ferrous oxalate plus 6/5 in case of ferric oxalate plus 1/5 in case of ferrous sulfate. So we have to add this. So it will become 6 plus 3, 9 plus 1, 10. 10/5 is equal to 2. That means overall we require 2 moles of MnO4 negative to oxidize 1 mole of ferric oxalate, ferrous oxalate and ferrous sulfate. Now friend, this is a solution of this question. If you understood this solution, please like, share and subscribe to my channel. Keep studying, don't give any gap. Try to become an employer, not an employee. And friends, thank you for watching this video.